Hello everybody, welcome back to CCT 250. Got a little bit of a short one for you today. Maybe something we'll re-record later if I get some extra content for it. But right now I want to kind of stick close to what's in the textbook because there is a fair amount to absorb and it is deceptively condensed. So let's get started with Chapter 12, Linux and Penetration Testing. So our key concept for this chapter is going to be Linux as it relates to pen testing, and it's a couple of different avenues we're going to follow. Some basic concepts of Linux, how it differs from more conventional operating systems that you would have seen. Most likely Windows is going to be the one you've seen the most. Some common distributions, also called distros. Kali Linux as it relates to hacking and pen testing, specifically built for that. Some benefits of using live distros, live USBs, live DVDs, etc. And then a little bit of talk about VMs and Linux. So our key terms for this chapter are going to be things like command line interface, general public license. GPL comes up a lot when you talk about Linux and open source based operating systems. Graphical user interface, Kali Linux, kernel, Linux distribution, live CD or DVD, penetration testing, and virtual machine. So some terms we've heard before, but maybe in a slightly different context this go round. So Linux is developed by a guy named Linus Torvalds originally. Linus Torvalds, excuse me. Believe he is either Dutch or Swedish. I cannot recall right now. But he wanted to develop a variation of Unix that felt like Windows, felt accessible to someone who didn't have extensive computational knowledge. You didn't have to be, a mainframe guru to be able to use it. And he also wanted it to be free. It wanted it to be out there so that anybody could modify it and do better, because he obviously thought he could do better than the people at Microsoft, Paul Allen, to be able to fabricate an OS. So he wanted it to be a community-driven project. Now, just because Linux has a GUI doesn't mean it exclusively uses that GUI. It also works a lot in traditionally what's called terminal. Terminal is the command line driven interface to manipulate the Linux operating system. Source code is available per the general public license, or GPL, which the GPL dictates what is and is not allowed as part of your usage of this source code. Now, I also want to make sure that you're aware of the difference between open source and freeware. Freeware is free of cost, meaning that you can do whatever you want with the software as far as distribution goes, but you cannot charge for it, and in a lot of cases, unless they specifically state otherwise, you can't reverse engineer it. Open source doesn't really require reverse engineering insofar as the source code is already there, but a lot of Linux distros support themselves by means of charging for support, essentially paid development of the operating system. Some of them have a pay what you want model, some of them have donation pages, some of them have ad-driven revenue, which are not terribly popular. But there's a ton of different variations out there to keep it free or as close to it and honor the original intent of the GPL and the open source movement. The kernel, the core component of the operating system that makes it what it is, that processes information moving from the software to the hardware, is what, in most cases, defines what the distro is. Okay, so the Linux kernel is the basis for any Linux-based operating system, or any sometimes called a NIX-compatible operating system, because it would be Linux, Unix. There's a bunch of different variations. And the graphic that we've got here on the right is Linux KDE. Cool Desktop Environment was the original term, cool with a K. It was a wordplay on the older version of Common Desktop Environment for Unix. KDE Plasma 5 is the current generation, and as you can see, it has a very user-friendly, visually crisp analogy to Windows. It looks very much like Windows and a little bit more of the Mac polish. So you'll have the transparencies and animations and all that good stuff. So there's a couple of common distributions that I want you to be aware of, really just so you know that there are a ton of different implementations out there for Linux. So starting in the top left is the one that I'm most comfortable with because I've used it the most often outside of Kali, which is Ubuntu. Ubuntu is an African term from the Nguni people, meaning humanity to others with a connotation of I am what I am because of who we all are. Because society makes me who I am. It allows me to enhance who I am. So it's a sense of community. It's a sense of empathy. Big part of the open source movement is to encourage that sense of community. It's based on Debian, which we'll talk about in just a minute. Very easy user interface to work with. I think I'm still using 20.04 LTS, but I believe there's a 21 out there now, like Jiggly Jellyfish or Jiggy Jellyfish, I think might be out there. I think Kudu is the next one that comes up. Arch Linux is an x86/64 independent distro, so it supports both 32-bit and 64-bit implementations. It uses a rolling release model, and it has what's called the Pac-Man update system. And the arch came from the term, just the idea of an arch enemy. Not necessarily that it was antagonistic to Linux, but it just sounded cool to the developer. CentOS, the community enterprise operating system. It has been discontinued by Red Hat. CentOS was previously a fork of RHEL, or Red Hat Enterprise Linux, but it's also not dead either. It's been continued by derivatives called Rocky and Alma Linux. Elementary is based on Ubuntu. It has a lot of Norse mythological names. So right now, Yolnir, which is 6.1, was released on December 21st. So it's about a year old, and it's based on minimalism and accessibility. Fedora is dealing more with innovation, trying to get new iterations out quickly, exploring new features, really kind of the test bed. It is the preferred distro of Linus Torvald himself. Their life cycle is about 13 months. So if you think that cycling between versions of an operating system is a matter of weeks, that would be more of a feature release, but an actual iteration of the OS itself probably closer to 3 to 5 years. I think Windows' life cycle is around 7 years. Manjaro, which is based on Arch Linux, focuses on user friendliness and accessibility. So as you've already seen, Ubuntu is based on Debian. CentOS has spawned its own derivatives. Elementary is based on Ubuntu. Fedora, is based on the original core system, but it's focused out a little bit further on terms of newer techniques. So the implementations change dramatically. So you see these flavors, which is often the term that we use. A lot of forking. So if you're familiar with revision control and things like that, you have these separations of this is new code based on old code. The master branch, or the original version of the OS, will stay the same, but there will be this variation of it that makes things look slightly different. Or maybe focuses on a particular feature that somebody felt was in need of prioritization. OpenSUSE is open source. It was based on the Red Hat Package Manager. SUSE, I believe, is short for a German software company. It's community driven, as many of these are. So again, this is just kind of a variation of Red Hat. Debian is one of the oldest Linux distros and the basis for a number of different derivatives. It's run for nearly 30 years. It was released initially in September of 1993, and the releases are usually named for Toy Story characters, and I believe Bullseye is the current release. And then, of course, there's even more, but I won't drag you down on this one. I think we've run almost 5 minutes on just this one slide. Again, the point I'm trying to bring to light for you is there is a Linux variation for just about everyone. So Kali is a specialized Linux distribution that's packaged to be a pen testing platform. It's a successor to a tool that existed a while back called Backtrack. Really popular. It was built on Debian. It's designed for hacking and pen testing, for networks or for systems. It's used for security assessments in a number of different environments. It is not a desktop replacement OS. So installing things for Kali is going to be installing tools for the pen testing environment. It's not going to be installing, a version of Office or installing Steam or something like that. It is designed specifically for security. It includes a portfolio of tools that are used to break down the walls of an organization, electronically speaking, and analyze its internal structures. So here's the Kali desktop menu on the left. And something you'll notice is that the drop-down for applications has an enumerated list, meaning that it's not just a list that has individual items, but it has counting, so that you can expand out different items to look at a particular function. So you can see, if we go to number 5, password attacks, you're probably going to see Cain and Abel or John the Ripper, Dave Grohl. You'll see some different tools in there specifically designed for cracking passwords. If you're looking for stuff dealing with web applications, you're going to probably be looking at Burp Suite. If you're going to be looking at network information, that's probably going to involve things like Snort. If you're there's a ton of different items that are in there. There's also, some system services down at the bottom, forensics, so a lot of stuff in there. It's vital to understand if you're going to use Kali, what terminal windows are, what the different commands are, how the syntax works for different applications. And this is where, unfortunately, the nature of Linux can become problematic, is that there's a ton of different variations in these commands. But fear not. Because they have a common ancestor, these commands will share a common form. The interface can run from CLI or from GUI. I prefer CLI simply because it's easier to build scripting. Navigation, Linux directories are annotated with a slash, same way it would be in Windows, where you'd be like C:/user/public/documents to navigate. You see the same thing here. Except you'll have the drive, which will be like SDA, SDB, SDC, slash, and then you'll have your folder. So here we've got dev, HDAL/file, just indicates the partitions that separate different directories. The design for Kali is an awareness of built-in directories to allow administrators to monitor known or expected files and directories. So a lot of these tools are built with the idea that there are certain things that are considered true to form. It's considered to be common practice. So here's a couple of vital directories in Linux file system to know where things are. This is a pretty handy little cheat sheet. There's probably some cleaner ones that are floating around on the web, but for our purposes, this one's not bad. The /blank represents the root, so very similar to C:/ in Windows. Another thing that's important to note is that the slash is the opposite direction than what we would expect to see if we were talking about a Windows machine. /bin, this is where all of the binary executables are, predominantly for all system users, so it's a common folder, very much like the Windows folder, so where you would have, calculator, solitaire, etc. /boot is where it contains all of the startup and boot files. /dev, this is where all the files that dictate access between the hardware and the OS reside. So this is kind of like the kernel's nesting place. These can be thought of as drivers, by and large, in similar files. If you've explored Windows System 32 and some other aspects of Windows core operating folder, you'll see some similarities here. /etc. This is configuration information, and this is for files that have to be configured as well as applications. /home, this is kind of like your user folder in Windows. /lib is library files. This is mostly C object files, so it would be like .cpp or just .c or .h. Libraries are shared code that is incorporated into an application on demand. So if we have a set of library instructions, this can be used to allow an application to be slightly slimmer. We have modularity. We borrow a module from a previously existing script, we incorporate it into our program, and when the program is built and run, it's able to rely on those existing functionalities. Applications in the operating system store their library files in this location by default. So you may have what's called cross dependencies. So you may have a file that actually installs a newer version of a file, like a driver, and will cause another program to have slightly different affect, simply because that driver update may be slightly off kilter. Not necessarily malicious or even negative, but it may just cause things to behave slightly differently in terms of output. /mount, MNT. This is where certain temporary file systems are going to be placed, or if you have a large number of external drives, like my personal file server, I have /mount for where my external hard drive enclosures activate, so that way I can move information into or from it very quickly. If you look at CD-ROM, that's going to be under mount. DVD would be under mount. So if you have an optical drive, I know a lot of us don't necessarily use those anymore, simply because physical media is kind of diminishing in terms of its viability. /opt. This is an optional directory, hence the name. This is administrator discretion to install third-party software. So if we want to keep that separated, if we want to partition it in that way, we can. /proc deals with processes on the system. /root is the home directory of the root user, and it is separated from normal users, obviously. /usr a little bit later on. /sbin is system binaries, so that's close to normal bin. /temp is a temporary directory. /user, generic user directory. A lot of common files and folders. And /var. This is our variable directory. So this is where your variables for your print spooler, mail spooler, log files, and process IDs are generated and maintained. So there's a lot of information that you can pull from these folders. So knowing where these things are, knowing what to look for, and the appropriate structures are going to be vital for pen testing through Kali. The basic command structure in Linux is threefold. You have a command, you have an option, and you have an argument. Now, excuse me, you may have options or you may not. Obviously, that's where the optional comes from. But you will always have a command and an argument. Now, if you have a command with no argument, it is implied that it is a null argument. If you could pass it in as blank, no argument is still an argument. You'll hear people argue this to the death on Reddit and other boards. The name of a command consists generally of lowercase letters and digits, and it is case sensitive. So bear in mind, like if you type in date with a capital D versus date with a lowercase d, the capital D will not give you anything. Lowercase d will give you the current system time and date. Options modify the way a command works, as you can imagine. So ls, or list, the -a command generates command output that lists hidden files as well as normal files. So we can conjecture from this that the -a is all, meaning that it wants to not leave obscured files out of the generated list. So like previously, I want to go ahead and incorporate this. ls, list command, it's very similar to the dir, or directory command in Windows. A lot of similar options too. This is allowing us to list the directories and subdirectories and files in a given location. pwd, print working directory. This doesn't really have an equivalent in Windows. This will display the current location of the user within the directory structure. So if you get lost in the file system, or if you need a text referendum of where you are in order to incorporate that into a script, it's a nice way to be able to spit that out. CD, or change directory, is going to allow you to be able to switch between windows very quickly, being able to move between different directories. So some shorthand is going to be a little bit different. So if we want to go to the root, we go to /blank. // is the current directory. // is the parent directory. So to go up a directory, if you will. Tilde, the little wavy dash there, is the home directory for that particular logged on user. So the format is CD and then whatever your directory change may be. mkdir, or make directory, is going to create new folders, essentially. You put in make dir and then the name. Remove directory is the same thing. If the directory is not empty, it will not remove it. It's kind of like in Windows when you hit delete, it kind of gives you the are you sure. There's a more aggressive version of this called rm, which is where it will purge a directory that is not empty. So you want to be careful because it will not give you any kind of warning if you do it wrong. CP, or copy, this moves files from location to location. So copy basically loads it into memory, moves it to the second directory, and then deposits it onto the drive. Move is a little bit different. So there's copy and there's cut, if you will. Move, MV, transitions things from one location to another by loading it into memory, moving it to the new location, deleting it from the original location, deleting it from memory. Moving right along, live distributions. Live CDs or DVDs contain a complete and bootable operating system, runs completely independently, does not alter the existing operating system, and it gives you the benefit of being able to return to the system in a way that it was prior to the distro. So if you run the live distro, do its thing, and then once you eject and reboot, you're back where you started. This can be beneficial for several reasons, and I've given you about 15 of them here. You can try installing Linux on a new system. So you can run the Linux live install and you can put it onto a new drive. You can also run dual booting, which we see in multi-booting in the third column. Testing new software, evaluating hardware configs, seeing whether or not something will work without committing it to the drive. Repairing a damaged system, providing a guest system. A lot of kiosks. If you have like a live kiosk, or if you have a mall directory that's like a giant touch screen, things like that, a lot of those will have either something like a Raspberry Pi or a live distro containment for something like this, some version of Linux that gives you that interface. So that way, if need be, you just re-image the thing and it's back up and running, no matter what somebody does to it. Providing portable systems. Again, you just take that OS and plug it into pretty much anything, and depending on the hardware that's present, obviously performance may improve, but the system is generally the same as it ever was. And if you set it as being write protected, it doesn't allow you to make modifications to it. It can be used for cracking passwords, stealing passwords, resetting passwords. Not always the most benign of activities. Conducting pen testing. Multi-booting, as I said, which is where we put multiple operating systems on the same disk. By partitioning it. Performing forensic investigations. So if you use like a Tritech box, that will often act as a surrogate operating system for the system you're investigating, so that way you can copy things over without triggering commands inside of the OS. Providing a secure, unalterable OS. As I said, if you write protect the USB and it's running from a USB, or if you have a DVD version, you can't really keep writing to the DVD to alter it. And then we have persistent desktops and, as I said, kiosks. Some special purpose live DVDs and CDs and USBs would be Kali. Those are special purpose live boots. Password reset, rescue disk, and firewalls. So with Kali in particular, I tend to use it as a virtual machine. Most security professionals do. VMs give us the ability to run on a host computer without installing Kali or booting from an alternative media. So VMs let us go ahead and load Kali, examine a running computer, pause it, restart it. Cloning an image is a lot better than trying to work on a live machine, simply because there may be things that are trying to conceal malware. There are things that may change as the system operates. When the system shuts down, caches and things like that can be reset. Ton of flexibility and availability with a Linux virtual machine. So if you have not done so already, I believe you will do it in your labs this week. Go ahead and get a virtual machine set up on your system. Now, if you don't want to install VMware, which is a little bit more extensive, I get it. VirtualBox from Oracle works just fine. I use VirtualBox for a lot of things. It tends to be a pretty easy interface. Not a lot of customization, unfortunately, comparative to VMware Workstation, but it is something that is an available option. So that's it. Really simple. We kept it in less than half an hour this time. Basic concepts for Linux, hacking and pen testing, live distros, virtual machines. So we got a lot covered. So hopefully the last half hour or so has been really informative for you. If you have any questions or comments, as per usual, please contact me via the usual channels. You can go through the YouTube channel, Blackboard, my WakeTech email, whatever you like. Hope it helps. Thank you guys so much for your time and attention. I appreciate you as always, and I will see you next time.